Hey guys, another lesson for Precalc coming right at you. Today we're going to be doing notes on section 15.5. So we're going to use this guy. Out of all the sections of the chapter, I think this one's a little bit the most, I want to say, complicated. There's a kind of a lot of moving parts to it, but it's going to be totally fine. What I want you to realize is also on the very back of your packet is this lovely chart of numbers. Okay, this chart of numbers is going to be used today to find stuff. So when we, I'll make sure to pause enough so that you can, go to the chart and find the right stuff. But just know that you can always pause the video. So great, right? It's not like live where you can't pause it. So this will be super awesome. So let me get the PowerPoint pulled up and then we will get started and be jamming. So here we go. Let's see. Okay, we are going to be doing our PowerPoint for today. So today we're learning about the normal distribution curve, which is pretty cool. And so the first part of notes, I'm going to be honest with you, is a lot of writing because it's just like facts, okay? And then we'll get into the math part. If you don't have your scientific calculator handy right now just for basic calculations, can you please go nab that? So pause the video and nab that if you need to do that. Okay, so we have talked about already frequency polygons, right? So a frequency polygon was when we would gather the data in bins, right? And then we would make the bars touching each other. So if we took a frequency polygon, we could actually replace it by this smooth curve. Okay, now you've sort of seen this before. Probably you've seen oh, that's like a bell curve, and you would be totally right. Okay. So when we have a data set that's normally distributed, and the key words, and I'm not just saying this flippantly, but honestly, guys, the key words is this right here, where it says normally distributed, okay? So that is like a signal to be like, oh, I should be using this this chart and this normal curve stuff that we're going to talk about. It's called the normal curve, okay? So that word normal is not just to be oh, that's just normal. It's a math thing, okay? So that's when it's normally distributed, it's called the normal curve. The normal curve has all these fun facts about it. So you filled that in, the normal curve, on your notes, and then we're going to write down 4 fun facts. I'm just looking at the notes over here. So it has the general shape of a bell, and sometimes that's why they call it a bell curve. So the general shape is just a bell, and it has it tails off at the edges and then gets, really fat in the middle. Or not really fat. Yeah, really fat in the middle. It's symmetric about the vertical line that's through the mean. So remember, the mean was the average. So if you put the average right in the middle, it's symmetric. It's half is on one side and half is on the other side. At the edges, it approaches the horizontal axis at both extremes. So it does tail off, and it is, we should, what's the math word, right? When it is approaching something but not really touching it, it's like an asymptote to it. So it's asymptotic to the edges, which is pretty cool. And then what's kind of interesting about this is that the mean, the median, and the mode are all at the line of symmetry. It's just because of the data being normally distributed, it all sort of merges into that spot. It's the most popular spot right there at the middle of your bell curve, at the mean. Okay, so standard deviation, we actually talked about that in our previous lesson, how to calculate the standard deviation, right, given a set of data. And so now the standard deviation, we didn't really talk about what it was, right? What is a standard deviation? So a standard deviation measures how far the data varies from the middle, okay? So we have our mean, and then what we're going to talk about is that some of the data is within one standard deviation. So you go a certain amount of data on this side and a certain amount of data on this side, and then that's the within out, the more the data varies, right? So the total area under a normal curve, now I know this seems really weird and it actually involves a little bit of calculus. Who knew, but it does. The area under your curve, even though it actually never touches the x-axis, is represented by the number 1, okay? So all of the area underneath a curve is 1, which means that when we, in just a moment, are going to take part of the area, our numbers are all going to be less than 1. In fact, if you look at the back of your note packet right now, you will notice that all of the numbers are decimals, right? Every single one of those numbers is less than 1. And so all the answers that we come up with are going to be less than 1 today, okay? Why is that? Just thinking from a logical perspective, your curve is representing everything that could happen, right? So everybody's shoe size, everybody's SAT scores, like everybody's whatever. So it's all the things that can happen. So it would be all the numbers. So it's the total probability distribution. And then I think there's one more note that we're going to write down. This Greek letter that looks like, wait, let me get my little pencil back here. This Greek letter that looks like a U with an extra tail on the front, it's actually called mu. I know, did I say that right? Mu. It's MU, that Greek lowercase letter. And that's going to represent the mean of the data. I think before we had done like X bar, if I'm not mistaken, to represent the mean. We did X bar. And so, yeah, that was totally lovely. But when we do our probability distribution curve, this guy right here, this normal distribution, we are in fact going to use mu to represent the mean. Okay, so just know that mu represents mean. Okay, so for any normal distribution, these following rules hold. Now, these are not exact. They're a little bit rounded, but it's called empirical rule. And it's just like how much of the data, just like I was saying before, is within 1 standard deviation, and then 2 standard deviations, and then 3, etc. So you're going to write this down. 68% of the data lies within 1 standard deviation, okay? And we are going to, there's a picture right underneath, which is going to pop up in a second, but you can actually glance at it on your notes. When you have the mean right there, okay, you go 1 to the left and 1 to the right, and then that is 34% this way and 34% this way, and that's 68% total. If you go 2 standard deviations, it gets 95% of the data. So from everything, right, including the 1 standard deviation and now expanding it to 2, like 1, 2, and 1, 2. And then 99.7% of the data lies within 3 standard deviations of the mean. And so most of the data, think about that, most of the data lies within 3 standard deviations. And then there's just teensy little bitty like leftovers on the outsides. Okay, so you can see on this cute little picture, that is exactly, this is totally just pulled right from your notes, that it's illustrating this fact. So if you want to just add this information to the picture, this right here, right, that goes across is 68% of your data. Then this is 95%. So because that's 95% and they're dividing it up into like these bands, right? So like this band right here was 34%. Well, if from here to here is going to be half of 95, and then this part right here is already 34, then this ends up being 13.5 on this spot right here and this band right there. And then I should probably erase all those silly things. And then the 99.7 is the 3 standard deviations. It's, guys, and even this picture, it just depends on how accurate we want to be. I think in stats class, they do a little bit more accuracy. These are general things, okay? And so they just kind of talk about this general stuff. So a good strategy, oh, you're going to be so surprised, is that a good strategy is to draw a picture. Of course. Why would we not draw a picture? In fact, if you look at the rest of your notes, because this is like a 3-page note guide today, if you look at that 3rd page, every single one of them has 2 little pictures that you want to draw. So when you're doing your assignment, whenever you're doing one of these questions, you're just going to draw like 2 quick little pictures. Doesn't have to be perfect. You're just drawing them as a sketch, okay? So I think that you should draw a sketch and then shade the area that you're looking for, and it just helps you like parcel out what you're supposed to be looking for. It's a really good strategy. We're going to go ahead and turn our page here. And the first questions we're going to ask ourselves have to do with things that are at standard deviations, okay? So apparently this says that you can debate this all you want to, but this is just our question. IQ scores are normally distributed with a mean of 100 and standard deviation of 15. What % of the population has the following scores? So what percent would be between 85 and 115? Now, I think I put a lot of like extra writing on the PowerPoint, but let's just think about it for a second. If the middle is 100 and you go 15 up, you get to 115. And if you go 15 down, you get to 85. Folks, that is exactly one standard deviation on either side. So that's exactly what is coming up right now. So we have our mean, which is the mu, which is 100, and we have our 85 and 115, and then I shaded it in. So do you see on the picture on your notes, you're going to shade that in just real nice, lightly, is totally fine. And then what happens is that is exactly one standard deviation. So what did we learn? We're going to flip back to your notes, bloop, turn it over. Oh yeah, 34% and 34% makes 68%. So 68% of the data is between 85 and 115. Very cool. Okay, then we go to part B and it says above 115. Okay, so we already know that 115 is one standard deviation above, right? So here's the mean. Here's my 115, which is at a standard deviation, and it wants everything above it. Okay, so we're going to shade in that part over there. So it's everything above it. Maybe it's above it this way to you guys. I might have pushed my hand the wrong way. Sorry about that. And so we already know it's one standard deviation. This band right here is 34%. What is this band right here? Guys, you don't have to add up all the strips, okay? The mean divides the data in half. This stuff right here is actually worth 50% of the data. So you don't even have to make up the band. It's just 54%. So if this spot right here and right here, this spot right here, and this spot right here make up 50 and 34, that's 84% of the data. What would be left over, right, to get this stuff right here? I think what we should do is we should just subtract it from 100. So 100 minus that 84% is 16%. And now I don't have to add up all the pieces. You don't want to add it up because it is actually going all the way to like to every single like standard deviation pass, way high. And so you wouldn't be able to like add up all those pieces, but we can definitely do some subtraction, which actually kind of like I think feels like it makes more sense. And then for part C, it says below 130. Okay, so let me think about that again. So let me go to my picture. I have my mean of 100. I do 15 and 15 for my standard deviations, and that's 130. So kind of like what we did on the other picture, we're going to sort of like piece it out, okay? So this part right here is worth 95% of the data, and that over there is worth 2.5. I might have even, like truth be told, guys, I might have even just gone and said to myself, this part right here is worth 50. Right? Just do the 50 right there. This part would be 34. And then this last part over here, if I go back to my chart on the flip side of my notes, is 13.5. So this part right here is 13.5. See if I can make a little dot. It worked, guys. Yay. So 13.5. And then I would have added those up together. That's probably actually what I would have done instead of all those subtractions. So just another way to do it. Or you can be like, no, I totally like the way that the notes did. Okay, so now, as opposed to just floating it to you, okay, they're doing a sort of like a comparison question. So this is example number 2, and we're going to do a comparison. So it says that Sandy got an 80 in math and a 74 in psychology. And we want to know like which grade is relatively better, comparing it to like all the other people in the class, thinking about the mean and the standard deviation. So in the math class, it says that the mean was 72. So she's above the mean with the standard deviation of 4. And then in psychology, the mean was 66 and the standard deviation was 8. So how do our scores compare to everybody else? So which one's relatively better to everybody else? So let's take it and decide. What we're going to do is decide how many standard deviations each one is above the mean, right? Because she definitely scored above the mean. Her 80 is above the 72 for math. Her 74 is above the 66 in psychology. But which one is, quote, better, okay? So in math class, okay, her score, okay, of 80, her score of 80 This is like her score. So this is like kind of like, we're going to talk more about this in a second. This is the X value. And then this is the standard deviation. So this is her value. We subtract the standard deviation. And I get 8/4. Oh, and this down here, this is the standard deviation. So her score is the 80. The mean is 72. And then 4 is your standard deviation. We simplify this to be 2. So in math class, she scored 2 standard deviations above the mean. Now let's look at the psychology grade. So we're going to do the same thing. We're going to take her score, which was the 74. We're going to subtract the mean, which was 66. And then the standard deviation was an 8. This is only 1. Okay. So even though they're the same distance away from like as a score, like the 80 is 8 above the 72 and the 74 is 8 above the 66, the math score is relatively better because it's 2 standard deviations higher. So we can make a conclusion that the math grade was relatively better. Beautiful. Okay, so we, on our examples so far, have only done things where they were exact standard deviations, but like in real life, does that actually happen? Probably not so much. Okay, what is more likely to happen is that we're just going to get some sort of like value in the middle. And so just like randomly somewhere. So what if it's not exactly at a standard deviation? So this is where that table comes into play that I was mentioning at the beginning, right? Remember, it's on the back of your notes, your note packet, and it's this beautiful table of loveliness, and we're going to use that baby right now. So let me get my notes arranged here. Okay, what we're going to be using is a table of values using the z-score. So this guy right here is really important word, the z-score, and we're going to figure out how to calculate that. What's funny, guys, is that we actually did calculate it on the previous question. And so let's write down how to do it. The z-score is going to be the value, the x value, minus the mu all over the sigma. Mrs. Fox, I need to write that in English. Okay, let's do it. Okay, so z is equal to x minus mu all over sigma. And in English, guys, the z-score is the value that you want to focus on minus the mean, and then all over the standard deviation. They will probably like give you this information. They'll give you the value, they'll give you the mean, they'll give you the standard deviation, and then you're just calculating the z-score. It's going to be fine. We just need to like memorize this like it's kind of like a little equation, right? Memorize the equation. Value minus mean over standard deviation is your z-score. Okay. Now let's learn a little bit how to use this normal distribution table. So what's going to happen is you're going to put these values, you're going to put in a value, you're going to put in a mean, you're going to figure what that is, divide by standard deviation, and then you're going to figure out what this score is. That score is going to be found on your chart, okay? So the score is going to be listed over on the side, okay? So this stuff right here is going to be your z-score. Now, I just like clipped a small portion of the table just to show you how it works, okay? But the z-score, and then you just like read it on the chart. This guy right here is going to be the 10th place. So over here is the 10th place, and then up here is going to be the 100th place. So you are going to round whatever you get for your z-score to the 100th, and then you're going to sort of like almost like, you know, like battleship it, like, read the 10th place over on this column and then the 100th place on this, and then you find where they just, where they match. And then that's going to be your probability, the number for the representing I can't think right now, for representing your probability. Sorry, guys. So this curve, okay, there's actually more than one version of a z-table. Some z-tables, our z-table that you look at in the back of your in your packet only has positive numbers down here for the z-scores. There is another version that has negative numbers. We're only going to use the positive one just because it's the first time we've seen it and we want to make it easy for ourselves. And so it basically represents, and you can see this on the thing. So I know my picture is small, but it represents this guy right here. It's the area under the curve that is to the left of z. Okay, so can you write like this message right here needs to be written in the box that's next to that little example table. It's the value under the normal curve to the left of Z. And that is really important, okay? So let's do just like an example, just to be like, I don't even know what you're saying, Mrs. Fox. Let's try to do an example, okay? So it says that if we have a z-score of 0.31, let's say like we put something in and we found a z-score of 0.31. I'm going to go to 0.3 on the tenths place, okay? And then I'm going to go to 0.01 on the hundredths place, okay? Make that go into the table, and my value for the area is 0.6217. Of course, that is less than, okay, 1, which we knew was going to happen. So it's 0.6217. Okay. And so that would be the picture. All right. So it would be at point whatever, like my standard, my z-score was 0.31. So just be a little bit to the left. Nope, a little bit to the right of the mean, and then you draw your line, and then all of this area. See if I can get my thing. All of this area right here, right? All of this area, okay, represents 0.6217. So your mean on your picture would be maybe like right here, and then you would put like a little dash right here, and you're going to write like 0.31, and then you look at your z table and know that all of this area is represented by 0.6217. Okay, what if it happens that your z-score turns out to be a negative value? Well, then it's really important to draw the picture, okay? You're going to just have to use some symmetry. You're going to have to think a little bit. You're going to be totally fine, but you're just going to have to draw a picture to illustrate it. So let's try some of these guys, okay? Let's try some of these. So we're going to use the table and find the indicated areas under the standard normal curve. Please note, please note, and this is how you're going to do your work, that for every single one of these, there are 2 pictures, okay? One of them is going to represent what you want to find, and then one of them is going to represent what the table is telling you. You may have to do a little bit of adding or subtracting to figure out what you want to match up with what the table says, or maybe it'll be exactly the same thing. We don't know until we draw the picture. So the picture is going to be so important. I know that we make fun of Mrs. Fox because she says that all the time, draw a picture, but like, no joke, you guys, you have to draw the picture on these guys. It's super not optional. So if you want to find the area between 0 and 1.03, a z-score of 0 and a z-score of 1.03, it's going to be really close to 34% or 0.34, because it's just this 1.03 is just a teensy smidge above 1 standard deviation. So this is what we want to find. Now, guys, it doesn't have to be perfect. Down here on the bottom of the curve, like there's a bunch of, where's my little mousy mouse? There's a bunch of like numbers down here. You do not have to write those numbers down. I could care less. Okay, what I really want to happen for your drawing is I want you to like draw it in the middle, put your 0, and then just go over here and write 1.03. If you can do that, I'm golden, right? And then just like color, all of this stuff. Okay, well, don't color outside the curve, but color all of those things, and then you'll be golden. Okay, so now what we're going to do is we're going to look on our table. Okay, the table is going to give us, right? The table is going to give us this entire area, the whole shebang, the whole thing, right? All the way from 1.03 all the way down to here. So we can see visually, folks, that this picture right here is not the same as this picture. When I get the number from the table of all of this area right here, I'm going to have to do something with it to get it to be this guy over here. Okay, so we're going to talk about that in just a second. Let's go to our table. When I look at my table, I'm literally going to look at it right now. I'm looking at my table. I need to go to 1.0 on the vertical side. I go to 1.0. I go over to the hundredths place of 0.03, and it looks like the number is, if I'm not mistaken, 0.8485. 8485. Now we know that this picture from the table is not, this picture right here is not the same as this picture right here. So instead, what we're going to do is, how are these related to each other? Well, folks, it looks like on what we want, half of the data, all this stuff right here is missing. Okay. What does half the data represent? Half of the data is 50%. So we're going to take the 0.8485 and take away 50% of the data. We're going to take away 0.5. The real answer to the question is 0.3485. This little strip right here, this little strip is representing 0.3485 of the area, okay? And didn't I say at the beginning that I knew it was going to be just a little bit above 34%? It totally makes sense. I love math when it makes sense. Okay, let's go for this one. This says a z-score, oh, here we go, between negative 0.9 and positive 0.9, okay? So I'm going to draw my own picture. I have identified where the middle is, okay? So I've got the middle right here. Here's my middle. And then I'm just going to mark over here, just draw a mark and draw sort of like a symmetric mark, negative 0.9 and positive 0.9, okay? On my chart, I can only look up this positive 0.9. It'd be 0.90. That's all I can look up. And it's going to give me this entire region. Okay, I'm going to work with that, though. So I go to my table. On the vertical column, I go to 0.9, and then on the top, I just go to a 0, 0.00 for the hundredths place, and it looks like the area is 0.8159. 8159, I got it from the table. So now what I'm going to do is I'm going to think about how is this picture right here related to this picture over here. Folks, I need to take off half of it. Okay, I need to make sure all of this goes away. And then whatever I get for this spot right here, I'm just going to double because it was symmetric. There was this spot right here, and then I'm just going to double it for this. So if I take 0.8159 and subtract half, I get 0.3159, and then we decided that we were going to double it, okay? So I'm going to double it, and my answer is for a total of 0.6318, and that's how it works, okay? Let's do a third version, okay? The third one says to the right of 0.81 of a z-score. Let's draw a picture. Okay, so I know that this is the 0 right here. This is 0. And then here is I put a little dash. And I put 0.81. There it is. That's beautiful. And then now I'm going to figure out what this is. Okay, so if I look up a z-score of 0.81, it's actually going to give me that picture. Okay, well, let's start with that. I go to my table. On the vertical column, I go to 0.8. On the top column, I get at 0.01, and it looks like the number is 0.7910. Okay, now what am I going to do? Well, how is this picture right here related to this picture right here? You know what you could say? It looks like it's the exact opposite. It's the exact opposite, you guys. Okay, so here's the deal. All of this right here, the one that we're actually trying to find, is the white space that's right here. It's the empty stuff. So how could I do that? Well, here's what I know. The area of the entire thing is 1. So if I go 1, take away what I found on the table, that's going to give me the answer. Okay, so 1 take away 0.7910 is 0.2090, and that's your answer, 0.2090, just like that. Whew. Let's go to a fourth one. So guys, it's different every time. I don't think you can memorize something. It's not like, oh, always subtract 0.5 or always do blah, blah, blah. It doesn't work that way. You just need to draw a picture and logically figure it out, okay? So let's try this one. This has a z-score of negative 0.81. Okay, not a problem. I have my picture. I have the 0 spot right here. I know that this spot right here, right, is 0.81, and it's a, let's see if we can make that dot a little bit bigger, and it's a negative 0.81, okay? If we look at the table doesn't have negative numbers. That's cool. It's going to give us the positive number. So I look up on my table again, 0.81, which I did in the previous question, and I get 0.7910. Now, how is that related to what I want? Guys, this picture right here is like the exact same picture as this one. It's just flipped. So I don't even have to change anything, folks. The answer is 0.7910. Whoop, whoop. Good job, me. That represents the area. Okay. That's what you're going to do. So some of the questions are literally just going to ask you to find the area under the curve given the z-scores. Great. But then sometimes you have to find the z-score. Oh, okay. That's our last example. Actually finding the z-score. Okay. So when we actually find the z-score, what's going to happen is you're going to do a calculation first on your calculator and then look it up in the table. Okay. So an automobile manufacturer claims a new car gets an average of 42 miles per gallon. Excellent. And the mileage is normally distributed, standard deviation of 4.5. If it's true, what percent of new cars will get less than 40? Okay, so what we want is, this is important, 40 is like a number that we want to latch onto, 40, but also less than. So that's going to influence my picture that I'm going to draw. Okay, so first we got to find the z-score. Remember we talked about for the z-score, you're supposed to do your x value minus the mu for the mean, and then over the standard deviation. So I'm just putting these values in. My value is 40 minus 42, the mean, over 4.5 for the standard deviation. I'm going to calculate it right now. Can't be left out. 40 minus 42, and then enter, and then divided by 4.5. I got negative 0.44 when I round, negative 0.44. Great. Okay. So now that I have that, now I'm going to say, what do I want? So on your note paper, there's a curve for what I want. I want, here's the middle, right? Here's the middle, negative 0.4. So I'm going to put a dash right here. I'm going to go negative 0.44. So this is negative 0.44 right there. Beautiful. My point's a little bit teensy-meensy. Okay, so negative 0.44. And now I'm going to figure out how to find this area right here by looking up something on my table. The table is going to give me the 0.44 version. Okay, I go to my table. The tenths place is 0.4. The hundredths place is 0.04. It looks like that number is 0.6700. So again, you have to ask yourself a question, self, how is this picture right here related to this picture right here? And I think, guys, that it's the opposite. This area that is what you want is this whited out space right here, okay? So we use some symmetry, and I'm going to have to take 1 minus 0.6700. When I do that, I get 0.3300. So it says, because the question says, what percent of the new cars will get less than 40 miles per gallon? It's 33%. If the question, and we're done, okay? But if the question had said, what's the probability? Then you would just write the answer of 0.3300. Okay, you know what's great, guys, is that if any of that part of the lesson was confusing, you can always go back and watch it again or pause it or do all the great stuff. So this is your homework. I will totally post it in Google Classroom also. Again, with our protocols, you're going to take a picture of the homework assignment when you do it. I should see legit tons and tons and tons of little pictures, right? Here's what I want. Here's what the table says. Here's what I want. Here's what the table says, just over and over and over again. And then please utilize in the back of your packet, okay, you're going to be utilizing this table right here. So come visit me in office hours. I would probably give it a go first and then see if any of those questions don't make sense. Okay, so I am going to get out of here. You can see my face one last time and we can say, I'm bye, Mrs. Fox. It'll be so great. So yeah, basically that's it, guys. So good luck on that lesson. I think you guys are going to do amazing, and I will talk to you later. Bye, guys. Have a great day. See you. I'm still